Hi everybody. Today I want to talk to you about conserved quantities and how in physics we basically keep track of what's going on with conserved quantities. So to get us started, I know that most of you have taken chemistry and you're probably familiar with conservation of matter that you learned about last year. And you did a lot of work taking inventory of how many atoms did you have initially and how many finally, even though during a chemical equation these atoms can be rearranged. If you start with 4 oxygen atoms on the left side of the equation, you would expect to find 4 on the right side of the equation. And in science, we like to study a lot of different conserved quantities, and we're going to be studying momentum soon. But before we do, I think it's important that we learn how to keep track of what's happening. And so today we're going to talk about a conserved quantity that everybody loves. We're going to talk a little bit about money. So if we think about a constant quantity, that's a quantity that does not change during a process. If some quantity is constant, that means that the amount you have initial equals the amount you have final. When we think about a conserved quantity, it's a little bit different, because a conserved quantity can change during a process, but we're actually able to account for that change. So we know where it went if we tend to lose it, or if we have more in the final state, we kind of know where it came from. So let's talk about conservation bar charts. This is a representation that physicists use to kind of keep track of everything that's going on. So if we think about money, we can have money in these different forms, right? So maybe you have some cash money in your pocket. So what I'd like to do is I'd like to represent that with symbols. So I'm going to say money in your pocket initial. I'm going to give that the symbol P with the subscript I. You can also have money in your bank account. So let's say we'll call that A initial. Maybe you have some money in your bank account attached to your debit card. And you can have money in the form of gift cards, maybe. So we'll call that GI. Well, that means that if these forms of money are available in the initial state, even if some process happens, we can account for how many we have in the final state. So I'm going to draw those over here as well. And notice I made the subscript F on each of these for final. Now, in terms of money, how do we end up with more than we had in the beginning? Or how do we end up with less than we had in the beginning? And that would be that we earn or spend it. So what I'm going to do is, I know that the sum of these initials should equal the sum of these final forms of money plus anything that I earn, so we'll give that a little E, or that I spend, so I'll give that an S. So in order to denote what we have here, I have this 0 line, so it represents 0. If you spend money, we'll give this a negative value. And if you earn money, like from working, then we'll give that a positive value. So if you imagine a scenario where you have, let's say, 50 bucks in your pocket, and then let's say you have $100 in your bank account attached to your debit card there, and maybe for Christmas or something your aunt gave you a $25 gift card to Target. Who wouldn't want that? So notice when you make these bars, you would make them relative sizes here. So I have 50, about half of the 100, and this 25 here is about half of the 50. So this is what we call the initial state. You would expect, and let me just draw this line down my equal sign, you would expect anything on the right of the line to have the same number in terms of the sum of all of these forms of money in the final state. So what we're looking for here is 50 plus 100 plus 25 gives us 175. So we can have a small problem, and you'll look at these problems in class today. Let's imagine that this is your financial situation. You've got $50 in your pocket, $100 in your bank account, $25 in gift cards. And let's say you go to Target and you decide you want to buy, a new video game or something for $50. So you use the gift card that your aunt gave you for Christmas, and you use another $25 from your pocket. How would this money bar chart look? Well, if I use $25 that was on the gift card, then in the final state, the gift card has 0. So you just draw in a 0 here. If in the end here you have spent $25 out of your pocket, that means that there's 25 still in your pocket. And there was no discussion of a change in your bank account, so this, A final, stays 100. So basically what you did was you spent $50. So I'm going to give, where it says earn, spend, we're going to make this negative 50. And so if we wanted to draw or write a math equation for this, we use the bar chart to come up with a math equation specific for the problem we're trying to solve. So in this case, I could write a math equation that says money in my pocket initial plus money in my bank account initial plus any gift cards initial plus anything that I earn or spend equals money in my pocket final plus money in my bank account final plus any gift cards. And here, this is what our math statement looked like for this particular problem. So it's always plus, but if you spend it, it'll be negative. Notice the sum of all of the money on the left, so 50 plus 100 plus 25 is 175. Plus a negative 50 gives you positive 125. And on the right side, we also have 125. So these forms of money are conserved. You might be wondering, why are we talking about money in physics class? Well, we really want to get the hang of what it means to be an isolated system and what it means to be a system that's interacting with external objects. When it comes to money, your money could stay constant if you didn't earn or spend it. So this particular column that you see in the middle here, right here, this is what makes money conserved and not constant, this change between you personally and then the outside environment. And there's a great analog for this when we start to study conserved quantities in physics like momentum and energy. So have fun with these money problems that you'll see today, and I look forward to looking more into momentum and energy using these similar processes. Let me know if you have any questions, and I hope you have a great day.